Deepseek.
Deepseek just dropped another groundbreaking open-source tool that could shake up the entire AI industry. For years, Chinese AI companies have relied on NVIDIA's expensive GPUs, but Deepseek might have just found a way to break free. This could be the most significant breakthrough in AI computing worldwide, because Deepseek actually has the capability to bypass CUDA, or even NVIDIA entirely. The tool released is called DeepEP, and it's the industry's first open-source EP communication library specifically for MOE, mixture of experts, model training, and inference. Think of it like a highway system built for a special kind of AI model, helping different expert parts of the model communicate efficiently. Even from the name, you can tell it's a serious, high-performance tool for AI engineers. Just from the name, you can tell it's a hardcore tool. To make it easier to understand, let's break it down into two key concepts. MOE, Mixture of Experts Communication Library. So what is MOE? As we mentioned before, Deepseek has two key technologies that enable ultra-low-cost AI model training. MLA, which we discussed before, helps break through NVIDIA's CUDA limitations and bypass GPU memory constraints. MOE, Mixture of Experts, the focus of today's release. MOE isn't new. It was first proposed in 1991, and its core principle is simple: dividing AI models into specialized expert networks. Think of a large AI model as a hospital. Traditionally, whenever a patient came in, all the doctors were called in to diagnose and treat them, which wasted a lot of resources. MOE changes that. It's like assigning doctors to different departments. Patients are only sent to the specialists they need, making the system far more efficient. Sounds great, right? The problem with MOE is communication bottlenecks. However, as AI models have become more complex and users have started asking more specialized and difficult questions, a single department or expert is often not enough. Now, multiple specialists need to work together, just like a multi-department medical consultation. But here's the issue. MOE's biggest bottleneck is slow communication between experts. That's exactly what DeepEP aims to solve. How does DeepEP improve MOE? Think of MOE, Mixture of Experts, like a team of specialist doctors working in a massive hospital. But here's the catch. This hospital isn't just one building. It's spread across multiple locations, with doctors in different departments needing to work together. Now, imagine, each hospital server has multiple specialists, GPUs, and chips. For complex cases, doctors need to consult across different hospitals, devices, but the communication between them is slow and inefficient, delaying treatment. That's where DeepEP comes in. It acts like an instant, high-speed communication network, allowing these specialists to seamlessly share knowledge, no matter where they are. With DeepEP, the experts can now instantly share patient information across hospitals, GPUs, and servers, communicate in real time with zero delays or data loss, work together as a single super doctor with a shared brain. The impact? Communication speeds between experts increase to tens or even hundreds of gigabytes per second. Drastically reduced delays, making AI models work much faster and more efficiently. In short, DeepEP turns scattered AI experts into a synchronized, high-speed medical team, ensuring they work smarter, faster, and more effectively. Two hidden superpowers in DeepEP. DeepEP doesn't just speed up AI communication. It also comes with two extra game-changing features that make GPUs even more efficient. Superpower number 1, multitasking. Like a pro before, GPUs had to choose between talking, communicating data, or working, processing calculations. Now, with DeepEP's new parallel computing method, they can do both at the same time, just like a chef who can chop vegetables while talking on the phone instead of stopping one task to do the other. Superpower number 2, precision control over GPU. Power GPUs are made up of tiny computing units called streaming multiprocessors, SMs. Normally, developers don't have much control over how these units are used. But DeepEP changes that. It lets them fine-tune and allocate resources exactly where they're needed, like a traffic control system that directs cars to the fastest lanes, making everything run smoother and faster. In short, DeepEP makes AI models faster, smarter, and way more efficient, without requiring extra hardware. In fact, Deepseek's master plan is beyond NVIDIA. Looking back, the first release was all about breaking GPU memory limitations. This second release is about enhancing GPU communication. Together, these two breakthroughs push GPU performance to its absolute limit. In fact, Deepseek seems to understand NVIDIA's chips even better than NVIDIA itself. What's even more interesting? They just released a tool that lets developers directly control computing units. This raises the question, is Deepseek moving toward a future where they can fully bypass CUDA and create their own full-stack GPU optimization framework? Could they eventually develop a completely independent AI computing framework? Of course, for now, Deepseek's tools still rely on NVIDIA's chips and architecture. Other AI chipsets haven't yet reached the same performance levels, but considering they've only been open sourcing for 2 days, they've already made a massive impact. Deepseek's tools are fully open source, ready to use straight out of the box. No hidden tricks, just pure innovation. Some developers are even saying, if it weren't for Deepseek's open source releases, my project wouldn't have progressed at all. The bigger question is, could these breakthroughs shake up NVIDIA's dominance in the AI hardware market? Will other companies learn from Deepseek and innovate even further? Stay tuned. We'll be covering the next big AI developments as they happen. Follow me to stay updated on China's cutting-edge AI advancements.